Hello everybody, welcome to this vlog. My name is Satya. So today we'll be discussing about router static routing. So basically we need to understand first what is a router. Router is a network element in the internet where more than one interfaces are present. When I say interface, the connection to the internet will be more than one interface. So let's draw a pictorial representation of router. R2, and we'll have two PCs, PC1 and PC2. So PC1 connects to R1, R1 connects to R2, and R2 connects to PC2 on that interface. Let's call it as the PC1 interface has 1, this has 2, this has 3, this has 4, this has 5, so this has 6. So there are totally 6 interfaces in this topology. So what happens in the static routing we will discuss here. So first of all, we need to understand what exactly is static routing. Static routing is an entity where we define the routing entries manually in the router paths, right? So instead of running it from dynamic routing protocols like OSPF, RIP, ISIS, etc., there are different routing protocols. So these are the four main, or three I should say: OSPF, RIP, and ISIS, which are majorly used in enterprise and the core network for routing the packets, right? For routing the for exchanging the routing information. Then routing the packets is a different. It's taken at the data layer. So usually sending the routing addresses or exchanging the routing addresses is a control plane feature, what I understand, and routing the actual data packets is a data plane feature, right? So here, since we will be working on static routing, we will be checking the or working at the control plane level. So as I told in previous vlogs where I discussed about home router, DHCP, Wi-Fi and NAT, there I discussed about PC1 getting the address automatically. So what we can do is, since it is a test topology, we can have PC1 for one interface number 1, and R1 interface number 2 in one subnet. Here 3 and 4 will be in separate subnet, 5 and 6 will be in separate subnet. So PC1, let's suppose IP address is 192.168.0.1. Here the second interface is named as 192.168.0.2. Okay, so either the PC1 is a Linux PC or Windows PC, you can easily configure an address manually, right? So when I say manually, you need to define 192.168.0.1 address to have a subnet mask and the default gateway, right? Here in static routing, we will not discuss about DNS. So it's all about sending a packet from PC1 to PC2 through these interfaces. R1, R2 are the interfaces, right? So how will we define PC1 IP address? So let's say we have PC1 IP address as 192.168.0.1. Okay, net mask, which is called as subnet mask, is 255, 255, 255, 255.0, and the default router, that is default router, is 192.168.0.1. That means to say, sorry, this is 0.2 default router, because the IP address from the second interface of R1 will be the default router for PC1 to route the packets, because there is no other interface connected to the network, right? So it has to go through all the packets. I have to go through on the first interface. So this is how we need to define the network on PC1. So IP address is 192.168.0.1, netmask is 255.255.255.0, default router is 192.168.0.2. Okay, so let's say first, to make sure that these two interfaces are working fine, what we need to use is a tool called as ping. Ping is known to most of the network troubleshooting people to have this ping tool to check the IP address connectivity at layer 3 is working fine or not. Okay, so we'll ping from PC1 192.168.0.2. Okay, since it's a default router, what first it will happen is you do ping 192.168.0.2 from PC1. What happens inside is PC1 will send an ARP broadcast packet to 192.168.0.2 to resolve into a MAC address. As I told, always the last hop in the network, the actual communication will happen using layer 2. So you need to know the MAC address of the uplink router, which is 192.168.0.2. Here PC1 will say ARP broadcast who has 192.168.0.2. R1 responds with ARP response unicast, saying that I am at particular MAC address. It's a layer 2 address, right? Let's suppose it is 00:01:03:04:05, right? So as I told, MAC address is 6 tuple long separated by colon, and IP address is 4 tuple long, each separated by dot. Once the ARP response is sent unicast to PC1 from R1, 192.168.0.1 PC will construct and ping works on ICMP protocol. It constructs an ICMP protocol with source as 192.168.0.1, destination as 192.168.0.2. This is the IP layer, and the network layer, which is layer 2, I should say MAC layer. You know the MAC addresses, right, that we got from PC1 will know its own source MAC address, and he learned the through ARP response the layer 2 MAC address of R1 interface 2. So you will populate it and you will send the packet. So once it is received here, the ICMP request, you will ask, R1 now will ask, who has 192.168.0.1? You will again send an ARP broadcast who has 192.168.0.1. Once ARP response is received from PC1 to R1, this time it's on PC1 to R1, the MAC address, he populates or constructs an ICMP reply with source as network layer, IP layer, source as 192.168.0.2, destination as 192.168.0.1. So this is how we can make sure that there is a connectivity between PC1 and R1 at the layer 3, right? So what another thing that PC1 and R1 will do is they will populate ARP cache for further communication. So PC1 ARP cache will have MAC address of this address, and R1 will have ARP cache with MAC address of this address, so that they can communicate between each other. So this is how we can make sure that PC1 is reachable from R1 and R1 can reach PC1 over interface 2 and PC1 can reach R1 over interface 1. So now the next question is, each interface on the router should be having a unique IP address, right? So you can't have 192.168.0.3 here. It will say it's not possible on R1. So what we need to do is, we need to define a different subnet here. So that subnet is 192.168.1.1 on 3, and on 4 192.168.1.2. So now the next, to accomplish the static routing, we need to define a static route here, saying that, or first we need to, once you define it, right, you send a ping from 192.168.1.1 to 192.168.1.2 to see that this link is working fine. That is, at layer 3 level, packets are exchanged between interface 3 and 4. So we ping from 192.168.1.1 to 192.168.1.2. Once ICMP reply is received, that means this link is fine, right? That is 3 and 4 are working fine. Now what we need to make sure is, static routing comes here, how to reach from interface 1 to interface 4, because they both are in different subnets, right? So for that we need to add a default route here in PC1, which is 0.0.0.0/0 points to 192.168.0.2. So any packet with a destination address other than 192.168.0.x, send it to 192.168.0.2, he will know what needs to be done. Now let's suppose we send a packet, ICMP packet again, from 192.168.0.1 with this default route in place in PC1 to 192.168.1.2. It will fail because this interface or this router does not know, I'm wrong here. So since we are reaching 192.168 1.2, after adding this IP address 192.168.1.1, it is already known here that this interface is the interface to reach 192.168.1.0 or 1.x. So no need to add any static route here. So we send an ICMP request from 192.168.0.1 to 192.168.1.2. It comes here, ICMP request, right? Here it will come to this, because that's the interface through which it is. Now 192.168.1.2 is our IP address. It will come to know in R2, right? Now when he starts replying, he doesn't have any route for PC1, because here 5 interface still no IP address is defined, and 4 is having 192.168.1.2. He doesn't have any entry to reach PC1. So here we need to add a static route saying to reach 192.168.0.x, go to 192.168.1.1. That means to reach here, go to third interface first, interface 3. So when R2 replies with ICMP echo reply, he will use the MAC address of interface 3 to reach destination MAC address. So it comes here, and then he will know where to reach 192.168.0.x network. So now we made sure that from 1 to 2 communication is fine, from 3 to 4 communication is fine, from 1 to 4 also communication is fine. Now finally what we need to achieve is we need to define a network layer 2 IP address for 5 and 6. Let's call it as 5 as 192.168.2.2 and 6 is 192.168.2.1. Now let's start by sending an ICMP echo request from PC1. 192.168.0.1 is the source address. Destination is 192.168.2.1, right? So before that, what we made sure is we made sure that 3 and 4 were working fine. The similar way we need to make sure 5 and 6 are working fine. So what we do is from 192.168.2.2 send an ICMP ping to 192.168.2.1. So same what we discussed in 1 or 2 will happen here. 1 to 2 will happen in 5 to 6. So all the ARP resolutions will be done, MAC address will be determined, and this link will be working fine, 5 to 6. Now as I discussed previously, we need to send a packet from PC1 from 192.168.0.1 to 192.168.2.1. Okay, so first packet, we have a default route on PC1 which says that any packet other than 192.168.0.1 send it to 192.168.0.2. Here it comes, right? Here now R1 does not know how to reach 192.168.2.x, right? Because there is no interface which is mapped to 2.x. So here in R1 we need to define a static route which says to reach 192.168.2.x, go to 192.168.1.2. Okay, so once you define the static route entry in R1, right, so you will send the packet through 3 interface to R2. Now R2 knows how to reach 192.168.2.x, so you will send it to PC2, right? Now PC2 received the packet which is from 192.168.1.1 to 192.168.2.1, but when he is trying to reply PC2, he doesn't know how to reach 192.168.0.1. So for that we need to add this default route In PC2, we says 0.0.0.0/0 points to 192.168.2.2, which is this address. So now PC2 knows, so send an ICMP echo reply. We send it from 6 to 5, right? 5 as the interface, IP address 192.168.2.2. Once it's reached here, right, he knows how to reach 192, R2 knows how to reach 192.168.0.1 because we already put a static route here. So he will come here. So this is how the static route works fine. So if you have any questions still with respect to ARP resolution and all, please put a comment. I will discuss in much more detail this same thing. Okay. So thank you friends for your time. See you in the next vlog. Bye.